Greatest common factor is known as the GCF. Greatest common factor is exactly that. It's going to be the factor that two numbers have in common, and you want the biggest one that there is. Okay? Very easy concept. Let's say, for example, I would like to borrow $20 off of somebody. And I say, hey, Jeff, can I have $20? And he says, no, you can't have $20 because I only have 15. Well, why can't I have 20? He only has 15. He can only give me what he has. Do we understand that? So if we're looking at 16 and 24, can my number be larger than my smaller number of 16? No. So with that said, what we're going to basically do here is we're going to look at the number 16, and we're going to find all the factors of 16. And those are all the factors: 1 times 16, 2 times 8, 4 times 4. And you're going to ask yourself, you're going to find the biggest number there is, which is 16. You're going to say, does 16 go into 24 evenly? No, it does not. Does 8 go into 24 evenly? Yes, it does. So therefore, my GCF is going to be the value 8. Do we understand that? That's the largest factor that is in common between those two numbers. Okay? Same kind of concept here, but this time I'm going to give you 12x squared y cubed and 32 y to the 4th y squared. This time I'm throwing some letters with exponents on them. So what's my smaller number up there? 12. So what are all my factors of 12? 1, 2, 3, 4, 6, and 12. And what do I start out with? The largest one. What's the largest one? Does 12 go into 32 evenly? No, it does not. Does 6 go into 32 evenly?
Yeah, no.
No. Does 4 go into 32 evenly?
Yeah.
Yes, it does. So therefore, 4 is going to be part of my GCF. Now, look at your x's. I have x squared, and then over here I have x to the 4th. How many x's are in x squared? How many x's are there in x to the 4th? So what you're telling me is I can only get the amount of 2 x's at a time. Does that make sense? So since 2 is the smaller exponent, I'm going to have 4x squared. How many y's do I have in the first term? 3. How many do I have in the second? So how many can I take? Y squared. Now, when you FOIL, what operation are you doing? Addition, subtraction, multiplication, division. Multiplication. When you FOIL, you are multiplying. Now, if I told you that factoring and FOILing are opposites of one another, what would that imply about the operation that you'd be using? That the opposite of multiplication would be division. And that's exactly what we're doing here. When you pull out a GCF, the operation that you're actually doing is dividing. You're making it smaller. And why is that? Because factoring and FOILing are inverses of one another. Now let's say I give you this new term called irreducible. A new term, irreducible, means I cannot factor. Cannot factor. It's irreducible. I cannot break it down into two binomials. The example I give you is 3a squared plus 9. Now the first question I have for you is, do I have a GCF in this 3a squared plus 9? What's my smallest value up there? 3. Is 9 divisible by 3? Yes. So therefore, do I have a GCF? I do. It's a 3. And I need to pull that out. When I pull that out, what operation am I using again? Division. So what's 3a squared divided by 3? 3a squared, sorry. What's 9 divided by 3? 3. Now, look at this. This looks a little different, doesn't it? My variables change. What's my variable normally? X. It's a squared. Is that okay? Sure. So what we're used to seeing is ax squared plus bx plus c, meaning I'm used to seeing a trinomial there. Do I have a trinomial there? I have a binomial. Can I make it a trinomial? I can by doing what? Making this 3 times a squared plus 0a plus 3. That 0a indicates that there is a middle term there, but whenever I multiply it by 0, what makes it happens to it? It disappears. Now, why did I put that middle term there? to show you that it's there, but to also show you that whenever we try to factor this, you'll see what happens. If I try to factor the two binomials, the first thing I need to do is get rid of that a squared. So what does that a squared turn into? A and A. The next thing is I need to make this a positive outcome. So how do I get a positive outcome?
Positive, negative.
Plus plus or minus minus. How do I determine that? Look at the middle sign. So that tells me plus plus. Now I need factors of 3. What are my factors of 3? 1 and 3, and that's it. Now, I need factors of 3 that are going to do what? Add or subtract? Are the signs the same or different? They're the same, so if the signs are the same, what are we doing? Adding. So I need these two numbers to add to give me 0. Well, what is 3 plus 1? Does that ever equal 0? No, because this does not equal 0. This thing cannot be factored into two binomials, and I have it being irreducible after 3 times a plus 3. Do we see that, yes or no? The answer is just 3 times a squared plus 3, yes. Write this down. Steps in factoring. This is a very simple concept. I tell you to write down the problem first. Yes, writing down the problem should seem very elementary to you. Then why don't you guys just write it down? Many of you just let it stay on the paper or write it straight from the textbook. You do not copy it down. Next, look for a GCF. Whenever I say look for a GCF, what are your eyes scanning for? Your eyes should be scanning for the smallest number that's there. Why am I looking for the smallest number? If I'm looking for the GCF, why would I look for the smallest number? Because your GCF cannot be bigger than the smallest number. Good job. Then, after you find your GCF, if it's only 1, do I need to factor out a 1? 1 doesn't change anything, does it? It's itself. So you're going to pull it out, you're going to do this by division, and you're going to factor what's left into two binomials if it's all possible. If it's not possible, then you're going to go ahead and make it irreducible. Do we understand that, yes or no? Are we ready yet? Okay, do this problem quickly. You have 30 seconds. We ready? Step 1, what's my GCF? Do I have 1? No, it's understood it's a 1 there, so therefore I leave it alone. I go ahead and put it into two binomials. How do I split up x squared? X and x. I need a negative, so what's that say about my signs? They're opposite, and if they're opposite, are we adding or subtracting? Subtracting. Now you're going to hear me use two words today, cemented or flip-floppable. Flip-floppable is not a word, I know, but it is a math word we're using today. Cemented means that if I flip the signs, it doesn't matter the outcome, meaning I can cement them and never move them again. Does that make sense? Flip-floppable means that I can change the signs if I want to, but if I change the signs, I change the outcome. Do we understand that? Okay? So, are these flip-floppable or are they cemented? They're flip-floppable because I can change the outcome, right? I can get a different number. I need to have a negative 5x, but I need to have a negative 14. So that's 1 and 14 and 2 and 7. So I need values of 14 that whenever you subtract is going to give you 5, negative. So I need a 2 and a 7. So what goes where? 2 goes with positive, the 7 goes over here, so that's 2x minus 7x to give you negative 5x. I know I'm right. Now, what is going on with this problem? How does this problem look different? It has a 2 in front of the x squared term, meaning I don't have to worry about just factors of the 12, I need to worry about factors of the 2 also. Do you understand that? So do I have a GCF? Is there anything in common between 2, 11, and 12? No. So I need to put this into two binomials. The first thing I want to do is break up 2x squared. Well, what are all the factors of 2? 1 and 2. So I have to use 2x and I have to use 1x. Do we understand that? So that's the only way I'm going to get 2x squared. Then I need to have a positive 12. So that's plus plus or minus minus. How do I know which one? Take the middle term, so I have to have plus plus. Are those cemented or flip-floppable? Cemented because it's not going to change the outcome if I were to flip the signs. Do you understand that? So, since the signs are the same, am I going to add or subtract? I'm going to add, and now I need to have factors of 12. That's 1 and 12, 2 and 6, 3 and 4. I need factors of 12 that whenever I place those in there, 3 and the 4, the 2 and the 6, or the 1 and the 12, and multiply one of those values by 2, and I add it together, I'm going to get what value? 11. Now it makes sense because 1 and 12, 2 and 6, 3 and 4, if I add those together, none of them give me 11, do they? Well, that's because I forgot about the 2. So I'm going to throw some values in here. I'm going to put a 4 here and a 3 here, and I'm going to do inner. Inner gives me 4x. Outer gives me 6x to give me a total of 10x. Is that what I wanted? No. So what do I want? What can I do? I'm sorry? Well, I have 4 and 3. Can I flip them? Sure, why not? I can turn this into a 3 here and this into a 4. That's going to give me 3x plus 8x, which gives me 11x. Is that what I wanted? Yes, so now I know I'm done. This is what we call guess and check. What we call is guess and check. Meaning I'm going to guess which factors I'm going to throw in there, check it to see if it works, and if it works, great. If it doesn't, I'm going to have to use different factors. Does that make sense, yes or no? Now, I can show you another method, or I can go right ahead and keep doing the same procedure. How many of you would like to see another method?
The other method easier.
I don't think so, but... The textbook 100% shows you the other method. Okay? The problem with the other method, I'm going to tell you straight up, is it tells you to take 2 times 12 to give you 24. And then take all the factors of 24 to give you 11. It works, but you're going to do it the other way. If I give you a problem that looks like this, if I give you what's 7 times 12, folks? See? Half of you don't even know what 7 times 12 is. So you're going to get 84, and then I'm going to say, what are all the factors of 84? You're going to say, oh. Right? So the other method, the problem that I have with it is you guys don't like multiplication tables. Therefore, you don't know all your factors. So the bigger the number, the harder it is for you to do it. Agree? The smaller the number, the easier it tends to be for you. So we're going to stick with this method so I can get more problems done for you in class today. Deal? Okay, I give you 7x squared minus 8x minus 12. Step 1, do I have a GCF? No, I don't, because 7 does not go into 8 evenly. And the only other factor of 7 is 1. So I'm going to immediately put this into two binomials. First thing I'm going to break up is going to be 7x squared. So what are all the factors of 7? 1 and 7. I don't have any choices. I have to use 1 and 7. So I'm going to use a 7x, I'm going to use a 1x. Do we see that? The next thing I need is going to be a negative 12. So what's that say about my signs? They're opposite. Are those cemented or flip-floppable? Flip-floppable because the outcome could change. Do we understand that? Now, since my signs are opposite, what does that say? What operation am I going to be doing? I'm going to subtract my inner and outer terms. Do we get that? So I've dealt with this. And now, what are my factors of 12? 1 and 12, 2 and 6, 3 and 4. Yes? So now, we have to strategically put 3 and 4 in there so that whenever I multiply one of those values by one of those numbers and subtract it from the other value, what number am I supposed to get? A negative 8. So, let's think about this. Do I want to use a 12 in this spot? Why do I not want to use a 12 on the clear right-hand side? Because I'm going to multiply it by 7, and that's going to give me a really big number. Am I going to get a really big number anywhere close to 8 when I subtract? No. So I know immediately this is not going to work. So my only two options are going to be the 2 and the 6 or the 3 and the 4. Well, let's think about the 3 and the 4. If I put a 4 here, that's going to give me 28, right? Is that going to work? What if I put a 3 there? I have 7 times 3. Is that going to give me an 8 anyway? No. So my only option is logically to use 2 and 6. Do you see how I reduced it down automatically by just using logic skills? Now, do I want to put a 6 in this spot? Why? Because 6 times 7 gives you 42. I don't want a big number like that. So if I use these, I'm going to have to put the 6 over on the left-hand side and the 2 on the right-hand side. Does that make sense? So I check inner, that gives me 6x. I check outer, that gives me a negative 14x to give me negative 8x. Is that what I wanted? Yes. So therefore, I know that this is right. Do we understand that? Okay, let's do it again. Step 1, what am I looking for? GCF. Do I have a GCF? What's my smallest number up there? Are they all divisible by 5? Yes, so I need to yank out a 5. Whenever I yank out a 5 or go fishing, what operation am I using? Division. So what's 5y squared divided by 5? Y squared. What's 5y divided by 5? Y. And what's negative 10 divided by 5? 2. So now, does that look easier already? It looks beautiful now because what's wonderful about this? The y squared, there's only a 1y squared there, right? So that makes our job so much easier. So now I'm going to go ahead and put this in two more binomials. And I have to break up y squared. So how do I break up y squared? Y and y. I need to have a negative 2. So if I have a negative 2, what's my sign? Opposite. Are they cemented or flip-floppable? Am I adding or subtracting? Subtracting. So what are my factors of 2 that I have to use? 2 and 1. And I have to subtract to give me negative 1. So 1 goes where? 1 is positive. 1 is positive. 2 goes into subtraction. Inner gives me y. Outer gives me negative 2y to give me negative 1y. Is that what I wanted? Excellent. This is number 58 in tonight's homework. Keep it in your notes for now. Okay. This is what we call perfect squares. Perfect squares are whenever you are dealing with numbers that are actually perfect squares. For example, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. All of these numbers right here are perfect squares. All of these numbers over here are perfect squares. That means you can break them down and tear them apart and be products of exactly the same number. 100 is 10 times 10. 64 is 8 times 8. Does that make sense? So whenever we come to a problem that looks like this, 9x squared minus 1, my question to you is the 9 a perfect square number?
Yeah.
Yes, it's 3 times 3. Is 1 a perfect square number? Yes, it is 1 times 1. Now, what this means is you want to write this as a lovely trinomial. I want your brain to see this as a trinomial. So what middle term am I always trying to get whenever I have a missing middle term? 0. So what we're going to do is we're going to break this down into two binomials. And how do I break down 9x squared evenly? Keeping in mind it's a perfect square. 3x and 3x. And then I need to have a negative 1. So what's that tell you about their signs? Their opposites. Are those symmetric or flip-floppable? Flip-floppable. So now I need to have a 0. And my factors of 1 are 1 and 1. Do you see that those are exactly the same parentheses except for what's different? The sign. That's what we call the difference of squares. Inner gives me 3x, outer gives me negative 3x to give me 0x. This is the difference of squares. Difference of squares. Why is that the difference of squares? Because 9 is a perfect square and 1 is a perfect square. Do we understand that? Okay, well now let's look at this one. I give you 12x squared plus 36x plus 27. Do I have a GCF? Well, let's look at the smallest number up there. What's the smallest number? 12. So that's going to give me 1, 2, 3, 4, 6, and 12. Is 36 and 27 divisible by 12? No. How about by 6? 36 is, but 27 is not. How about by 4? No. How about by 3? Yes, I have a GCF, don't I? So what do I want to do? I want to pull that out. So if I pull out a 3 by division, 12x squared divided by 3 is 4x squared. 36x divided by 3 is 12x. 27 divided by 3 is a 9x, or a 9. Now I want you to look at these numbers right here. What type of numbers are those? Perfect squares. 4 is a perfect square, and 9 is a perfect square. So what we're going to do is we're going to use those perfect squares. 2x and 2x, 3 and 3, right?
You always use them no matter what.
You always want to try them first, yes. Now, the kicker is what's my sign? And what's my sign here? Positive, which means my signs have to be the same. So if I check my inner gives me 6x, outer gives me 6x to give me 12x. Is that what I wanted? Yes. This is factored completely, but what I really want you to notice is that this right here is called the sum of squares. Do you have to use that? No. Could you use the same process we have been doing the whole time? Absolutely. Absolutely. 69. Smallest number? 10. Are they all divisible by 10? What's the next biggest factor of 10? 5. Are they all divisible by 5? No, what's the next biggest factor of 10? 2. Are they all divisible by 2? They're all even, so they all have to be divisible by 2. So I know I have a GCF of a 2. So I need to yank out a 2. So 18b squared divided by 2 is 9b squared. 24b divided by 2 is 12b. Minus 10 divided by 2 is 5. Now, is 9 and 5 perfect squares? No. So is that method going to work before? No. So I have to go back to the same old, same old. So I'm going to break this down into two binomials. The first thing I want to do is break down 9b squared evenly. So what do you think you should use? I'm going to use 3b and 3b. I need to have a negative. What does that say about my outcome? Signs are opposite, which means am I adding or subtracting? Are they symmetrical or flip-floppable? Okay. Now, back factors of 5. 1 and 5. Now let's think about this. Does it matter where I place the 5 right now? No, because the numbers are both 3, aren't they? Since the numbers are both 3, it does not matter whatsoever where I put it except for the signs. Do we understand that? So if I put my 5 in the first spot, I'm going to get 15b. Over here, minus 3b to give me a 12b. I know I'm done. Tonight's homework. We ready for it? You should have copied it down at the beginning of the period, yes, but I don't know if everybody did. 32 through 58 even and 62 through 78 even. Out of your textbook. Okay?